Alright guys, so we're going to be going over the Chapter 6 test review. Alright, so let's get started on this first one here. So the only thing that we really want to keep in mind on this one here is just that we have a parentheses there, and we're taking it to the second exponent. So as long as we keep those parentheses, we should come out with a positive answer of positive 4. And so what that's doing is just doing -2 times -2. That's getting us the 4. But if we didn't have the parentheses, then it would be doing the exponent first, which would get us that 4, and then it would be tagging on the negative sign afterwards. So just be aware of that. Alright, so So on this one here we got x to the 4th times x to the 3rd. And in this one we would be applying the product rule, and that's the one where whenever we're multiplying bases with exponents, we would add the exponents. So in this case we would have x, and then up here we would have 4 plus 3. And then just to simplify, we would change that into x to the 7th. And that would be our final answer there. Alright. Alright, so with this one here, we have y to the 14z in parentheses multiplied by y to the 8th and z to the 2nd. Alright, now on this one here, I would just handle it variable by variable. So first I just deal with my y's, and so in this one we would be using the same rule as last time, where we're adding up these exponents because we're multiplying with bases with exponents. So for the first one we'll have 14 plus 8, and close up that parentheses, and then we'll also have z, and one thing to keep in mind is that this z right here, if there's no exponent there, it's assumed to be 1. So we'll have 1 plus 2 over that z. And if we were to just simplify, we would end up with y, and 14 plus 8, that would give us 22. So y 22. And then for our z, 1 plus 2 is 3, so we'll be left with 3. So our final answer would be y to the 22nd and z to the 3rd. Alright, so let's get started on this next one. Alright. So in this one here we got z to the 3rd, and all of that in parentheses, to the 8th. Alright, and in this one we would be making use of the power rule, and that's the one where if we're taking an exponent to an exponent, we're going to have to multiply those exponents. So we'll have z 3 times 8 in the exponent. So what that'll leave us with would be z to the 24th. And that would be our final answer. Alright, so let's get on to the next one. Alright, so we got p to the 4th, q to the 3rd, and all of that in parentheses. We have an exponent of 2 on the outside. Alright. So the first thing to do whenever we're faced with this type of problem would just be to distribute this 2 to every term that's on the, every variable that's on the inside. So in this case, we would have p, and then when we're distributing this exponent of 2, we're going to have to use the power rule. So that's whenever we multiply exponents, whenever it's a power to a power. So in this case, p will have 4 times 2 in the exponent. And then now we'll have to do the same thing with q. So in this case, we have 3 on the inside times the 2 on the outside exponent. Alright. Then the last thing we have to do is just simplify this a bit. So I have p, 4 times 2 would be 8, so p to the 8th. And then with my q here, we'll have to do 3 times 2 in the exponent. So that'll leave us with q to the 6th. And then that would be our final answer for that one. Alright. Okay, so on this problem here, we're going to have to use the quotient rule. But first, let me just get this down. P to the 2nd, q to the 6th, all over p, q to the 5th. Alright. So on this one here, again, as I said, we're going to have to use the quotient rule. And in this one, one thing to keep in mind is just that if there's no exponent, we're going to assume that there's a 1 there. So let me just write that in there. So in the exponent rule, what we have to do, or excuse me, the quotient rule, what we'll have to do is we'll have to subtract the exponents for each variable. So first, let's start with our q's. So we got p, or excuse me, we'll start with our p's. So we got p, and then we'll do 2 minus 1 in the exponent. So I'll just put that in parentheses. Alright. And then for our q, we'll have 6 minus 5. Alright, so 6 minus 5. And then I'll just have to rewrite that just to simplify it. So I'll have p, 2 minus 1 would be 1. So I'll just put the 1 there. Yeah, generally you don't have to put the 1, but I'll just put it just for clarity's sake. And then the q, 6 minus 5, that would be 1 as well. So I'll put that there. But if you guys were trying to put that into MATLAB, just be sure to know that MATLAB's not going to want that exponent of 1 stuff there. So our final answer would just be PQ. Alright, so let's get on to the next one. Alright, so in this one we have parentheses negative 8x and all of that to the exponent of 0. Alright, the big thing to keep in mind in this one is whether there's going to be whether there's going to be parentheses or not. So in this case, since there are parentheses, that 0 is technically going to be distributed to everything on the inside. So we'll have negative 8 to the 0 multiplied by x to the 0. And if we were to simplify that a little bit, due to the rule of the exponential rule of 0, anything to the 0 is going to be 1. So in this case, negative 8 to the 0, that'll be 1. We'll multiply that by x to the 0, which will also be 1. That'll just leave our final answer to be 1. But one thing to keep in mind here is that if, for example, if our the problem that they gave us was negative 8 x to the 0, what we would have to do in this problem here is know that that 0 in the exponent is only associated with that x. So if I were to simplify it, it would be negative 8 times 1. And that 1's in place of that x to the 0, because anything to the 0 power is 1. Then it would simplify to negative 8. So it would be different in that case. And that's mainly because of the parentheses there. So just keep that in mind. So in this one here, we're going to be making use of that quotient rule. So here, let me just write this out. So we got we got 8x to the 6th over x to the 5th. And so for our coefficient, that 8 there, we're just going to have to leave that there because that's not going to have anything that'll be changed. And then for our x's, we're going to have to use that quotient rule. And that's whenever we're dividing with bases with exponents, we're going to subtract the exponents. So we'll just have x, and we'll have 6 minus 5 in that exponent. So just to simplify it, we'll be left with 8x. Since 6 minus 5 is 1, we'll just leave that 1 there in the exponent. But again, MathLab won't accept it with the 1 as the exponent, so just leave it as 8x. And then this one here, we have 3y to the 3rd all over 9z to the 2nd. Right. Okay. And then we have a 2 in the exponent on the outside. So in this one here, the main thing we got to do first that's different here is distribute the exponent of 2 to everything on the inside of this parentheses. So here, I'll show that here. So we got that 3, and I'll put the exponent there. I'll have my y, and I'll have my 3. And since it's an exponent to an exponent, we're going to have to use the power rule. So in our exponent here, I'm going to put 3 times 2, divided by, and I'll put 9, and I'll give that the squared, because of the exponent that we're still distributing. And our z, I'll put 2 times 2 as our exponent, because we have the 2 here times our 2, since we're using the power rule. And another way you could have done this also is that you could have just simplified the 3 over 9 initially, so then you won't have to deal with these big numbers, but we'll just go ahead with it the way that I started it. So let's simplify here. 3 to the 2nd power would be 9. And be sure you're not just multiplying like 3 times 2 to get to 6, because that's a common error. And so, and for our y's, we'll do 3 times 2 in the exponent. That will leave us with 6. And then 9 to the 2nd power, that would be 81. And z to the 2 times 2, that would be 4. But we couldn't leave our answer like that because we can simplify the coefficients here. So 9 over 81, that can simplify. And we can divide both the top and bottom by 9. So that'll leave us with 1 on the top, 1y to the 6th. Then it'll leave us with 9z to the 4th. And technically, MathLab may not want that 1 there, but I just put it there just so you guys can see where that 9 went. Alright, let's do this one. Alright, so we got 5x to the 3rd. Y to the 2nd, z, and I'm just going to put that 1 there because whenever there's not an exponent, there's always going to be an exponent of 1. Alright, so we got x to the 1st, we got y to the 1st, and we got z to the 1st. Alright, so first we'll just take care of the coefficients, then all the variables one by one. So we got 5 over 1. That invisible 1 would be right here. So we could just leave the 5 as it is. And then for our x's, we'll have to put that x. And then since we have exponents and we're doing division, we're going to have to use the quotient rule, and that's whenever we have to subtract the exponents. So I'll have 3 minus 1 here. And then I'll put down my y, and again, we're having to use the quotient rule, so we'll do 2 minus 1. Then for my z, I'll have 1 minus 1, so I'll put that here. Alright. So then we could simplify a bit. We got 5x, 3 minus 1 would be 2. Leave that as 2. Y, 2 minus 1 would be 1. So y to the first. But technically you don't have to put that first. And then z to the 1 minus 1, that would just be z to the 0. But since we know that anything to the 0 power is 1, I'm just not going to put that down there. Right. And then we'll just leave our answer as 5x to the second and y to the first. So in this one here, what it's asking for is the degree of the polynomial. Alright. Now, one thing to keep in mind in this one is the degree of the polynomial is the highest exponent of all the terms. Alright. And so in this case, we have a to the 8th there, we have a to the 1 there, and then that 6, it doesn't have a variable, so technically the degree on that 6 is just 0. So and out of those we have 8, 1, and 0. And since 8 is the highest number, 8 would be our degree in this case. Alright, so in this one we have 6x plus 9 in parentheses, and then we have that right by 2x plus 7. Alright, so in this one we'd have to use FOIL, and FOIL would just be first, inner, outer, last, and that just means that we're going to have to distribute that 6x to both the terms, and we'll also have to distribute that 9 to both the terms. Alright, so we'll have 6x times 2x plus 6x times 7 plus 9 times 2x plus 9 times 7. Alright, so we'll deal with this one by one. So 6x times 2x, that'll give us 12 in the coefficient, and x times x, that'll give us x squared. Alright, and then plus 6x times 7, that would give us, let's see, 42x. And 9 times 2x, that would leave us with 18x. And then 9 times 7, that'll leave us with plus 63. Alright, and before we would enter this in as our final answer, we'd want to combine any terms that we could, that are like terms. And in this case, we have 42x and 18x. So if I were to rewrite that, I would have 12x squared plus, let's see, that would be 50, or 60, that would be 60. So we'd have 60x plus 63. That would be our final answer. Yeah. And so on this one here, we would have to subtract two different polynomials. So in this case, this is the scenario where if it's subtraction, we're going to have to flip all the signs in that second parentheses. So in this case, first I'm just going to rewrite 12x squared plus 12. And then now I'll just flip the signs of everything in that second one. So originally I have 8x squared there. So I'll change that to negative 8x squared. And I have negative 1 initially, so I'll change that to positive 1 now. Alright. But once I've rewritten it, I am able to just combine any like terms. So right now we have 12x squared and negative 8x squared. So we'll combine those, and that'll leave me with 4x squared. And then 12 plus 1 are my last two left. So I'll combine those. That'll leave me with plus 13. That would be my answer, 4x squared plus 13. Alright, so I got 2x multiplied by, and then in parentheses I have 5x squared minus 3x plus 3. So in this one, we're going to have to distribute that 2x to every term on the inside. So we'll have 2x times 5x squared plus, or actually, we wouldn't have plus next. We'd actually have minus, because we have negative 3x times 2x. Since a negative times a positive is a negative number, we'll put minus, then we'll put 6x, or here, wait, 1 second, I'm skipping ahead a little bit. So we'll have 2x times 3x plus, and then we'll have our last one, which is 3 times 2x. Alright, and so now we'll start to simplify, since we've distributed that 2x out to every term. So 2x times 5x, that would leave us with 10x to the third, because we're going to be adding these exponents, and 1 plus 2 is 3. And then minus 2x, or minus whatever 2x times 3x is. And in this case, that would be 6x squared. And again, we're adding these exponents, and we're just doing 2 times 3 for our coefficient. Then in our last one here, we'll have plus 3 times 2x, that would be just 6x. And since we can't combine any like terms, we'd have to leave that as our final answer. Yeah, so in this one here, we'll have to do FOIL, so we're going to have to distribute that a to everything there, and also distribute the 7 to everything in that second parentheses there. Alright, and I'm just going to erase that just so it's easier to see. So we'll have a times a. Oops. Alright, so we'll have this a times that a. That'll leave me, and in here actually I'll do an extra step in between. So a times a, and then I'll do a times negative 3. So I'll do plus a times negative 3. And then I'll do 7 times a. So plus 7 times a plus 7 times negative 3. So 7 times negative 3. Alright, so here a times a, that'll leave me with a squared. And a times negative 3, that'll leave me with negative 3a, so I'll do minus 3a. Then 7 times a, that'll leave me with 7a, so I'll do plus 7a. And then 7 times negative 3, that would leave me with negative 21, so I'll do minus 21. Alright, and so I have two terms here that have the same degree of 1, so I can actually combine those. So in order to, before I circle that as my final answer, I'm going to have to combine those. So I'll leave that a squared. then negative 3a plus 7a, that'll leave me with 4a. Then my negative 21, I'll just have to tag on here, and I'll circle that as my final answer. And I'll have a squared plus 4a minus 21. Alright, in this one here, I'll have to distribute the x to each term on the inside of the second parentheses, and I also have to distribute that negative 4 to each term on the inside of that second parentheses. So I'll have x times x squared, and that's just from this x times x squared. Then I'll have my x times my negative 7x, so plus x times negative 7x. Alright, and then I'll have, so I've distributed to my first two terms. Now I'll have to do x times 2. So x times 2 plus, and then we'll have negative 4 times x squared. So negative 4 times x squared. And then for our next one, we'll have negative 4 times negative 7x. So negative 4 times negative 7x. I'm running out of room here, but I'll just write that down here. So in our last one is negative 4 times positive 2. So negative 4 times 2. Alright. So I'll deal with these one by one. So I'll have x times x squared, and we'll use the product rule, so we'll have to add those exponents. So we'll be left with, and here, I'll write it under here, so then you can see how it's simplified. So I'll have x to the third, for that right there, and then we have x times negative 7x, so that'll turn into negative 7x squared. Oops. Right. Plus x times 2 would be 2x. Negative 4 times x squared would be negative 4x squared. Then we have negative 4 times negative 7x. That'll leave us with positive 28x. And it would be positive since we have a negative times a negative. And then for our last term, we'll have a negative number because it's negative times a positive. So we'll have minus 8. Because 4 times 2 would be 8. Okay. And then now, we'll actually have to simplify one more time because we have some like terms here. So first I'll have to put down my highest degree term. So x to the third, I'll put that down. Then I'll just cross it out as I'm dealing with them. So x to the third is dealt with. And then I'll deal with my next highest term, or next highest degree. So 2 would be my next highest degree, and I have negative 7x squared, and I also have negative 4x squared. So that'll turn into negative 11x squared, because a negative minus a negative, or minus a positive, makes it more negative. Alright. And so we've taken care of these. Now we'll also have to combine this 2x and this 28x. That'll give us 30x. So cross those off. Then the last thing we have left here is negative 8, and I'll just have to carry that down. So this would be our final answer here. And so in this one here, we'll also have to FOIL. So we'll have to take this 5x to this 5x first. So we'll do 5x times 5x plus 5x times 4x. Or excuse me, there's not an x there, so it's 5x times 4. Then we'll do negative 4 times 5x And then we'll have to do negative 4 times positive 4. So, and we'll take care of that one by one. So we got 5x times 5x. That'll leave us with 25x squared. We got the x squared because we had to add up those exponents because we're multiplying bases with exponents. Alright, and on our next one we have 5x times 4. That'll leave us with 20 and with the x tagged on. In our second to last one we have negative 4 times 5x. That'll leave us with negative 20x. It's negative due to, and we're doing negative times a positive. Alright, and then for our last one here, we got negative 4 times 4, which would give us negative 16. Alright, and so here we can notice that we have some terms we can combine here, since they have the same degree on their variables. There's a 1. And since they're opposites of each other, 20x minus 20x, would just cancel out. So I can just rewrite my final answer as just 25x squared minus 16. And I'll circle that. That'll be my final answer. Alright, so in this one we have 6 to the negative 4. Alright, we got 6 to the negative 4. And the way we would deal with that is I would first make that negative exponent into a positive exponent. And the way we do that is that we change the side it's on of the fraction sign. So currently it's 6 to the negative 4 over 1. And so if we were to change the side of the fraction that it's on, we would change it from the top to the bottom here. So we'll put it 6 to the 4th down here. And notice how the only thing I changed was the exponent from being negative to positive. And I also have to put a 1 up here just as a placeholder. And then I could just calculate what 6 to the 4th is. And 1 second, let me do that. And that would be 1 over 1,296. Right. And that would be my final answer. Alright. So in this one here we got p to the 6th and p to the 1st. And technically they didn't write the 1, but I'll just keep it there because if there's no exponent near a variable, on a variable, that means that it's assumed to be 1. Now on the bottom we have p to the negative 3. Alright. So the first thing I would do here is we would want to combine these p's on the top here. So, and since we're multiplying bases with exponents on the top side, we would change, we would have p 6 plus 1, which would leave us with p to the 7th. Alright? And then on the bottom we still have p to the negative 3. Alright. And so we can't have any negative exponents in our final answer, so we'll have to fix that. Alright. And the way we'd fix that is that since we have bases with exponents that we're dividing, we'll have to use the quotient rule. And in that rule we were subtracting exponents. So in this one we'll have p, and we'll have 7 minus negative 3. Alright? And so since we're doing a positive minus a negative, what we'll actually be doing is 7 plus 3. So that would leave us with p to the 10. Now we can have that as our final answer because we don't have any negative exponents anymore. Alright. So let's go on to the last one here. Alright, so we got x to the 6th, y to the 3rd, and all of that's in parentheses, and we have all of that to the negative 8. So the first thing I would do here is to change this negative exponent into a positive exponent. And so just like last time, originally all of our stuff that we have here, x to the 6th, y to the 3rd, all to the negative 8th power, is all over 1 originally. So, and if I was going to change that negative exponent of negative 8 into a positive 8, I'll have to change the side of the fraction that it's on. So in this case, I'll have to move it down here. So x to the 6th, y to the 3rd, to the 8th. Now notice that it's positive now. And then on my top, I'll have a placeholder of 1. Right. Now I have to simplify that. And so what I'll do is I'll leave that 1 on the top over, and then you have to use the power rule here in order to distribute that 8 out to both the x and my y. So I'll have x 6 times 8, and I'll have y 3 times 8. And so if I was going to simplify that, I'd have 1 over x, and that would be x to the 48, and I'll have y, and 3 times 8 would be 24, so I'll have y to the 24. And that would be my final answer there. Oh, whoops. And that'll be it for our review. Thank you.